All right, well, let's take a look at the kernel. I'm going to share my screen again. I think this is the first time we've actually gone into the kernel in this class, probably, because it's the second class. So let's go into upstream kernel, do an update. And if anyone has any questions at any time, feel free to jump in. So I'm just updating all my rows. Probably don't need to update all of them, but I'm doing that anyway.
And again, I guess the idea is we want to see if we can figure out why there's a space being printed at the end of that message that was part of Chris's submission, because it's not his fault. It is part of the actual message from the kernel. So maybe we can figure out where that is, and maybe there's a good reason for the space there, or maybe there isn't.
Maybe there isn't, and then we can help with that. I don't know if it's even. They might say, "Oh, this is a feature, not a bug," for whatever reason. So, they might not really care, right? This is just for copying the output in. But I think generally, best practice is not to have an extra space, right? Because it's kind of an invisible space.
Mm-hmm.
So, all right, we got also all these trees. Let's see, we got this tree. We got the tip. There's another interesting tree. So tip stands for Thomas Gleixner, Ingo Molnar, and Peter Zylstra. I know, it's kind of weird, but it's just like a combined maintainer subsystem tree. Let's see, AKPM, that's Andrew Morton. Not sure what KP, if that's his name or if that's like kernel patch or something. Andrew kernel patch Morton. I don't know. I don't know if, yeah. Anyway, so MM is memory management. This is a memory management tree. So I don't know. And Linux Next is like kind of a staging ground for, managed by other maintainers. That some things might go in there before they actually go into the mainline kernel. And of course up here, the actual mainline kernel tree. So let's just see what branch we're on. Master, so merge origin master. And cool, so we got this huge diff stat like we saw before. A lot of changes since last time. And okay, so what exactly were we looking at before? Let me just let me pull that up. So here I can save this directory. It's kind of convenient. Push D dot, and you'll see how we'll use that in the future. Now we'll go to KDLP assignments and we'll look at git log -p, and we see right here we can see the white space error. And again, if Chris, you're watching this is not your fault. This is just there. And it looks like the line is EFI, SMBIOS, memmatcher, memreserve, right? So it's somewhere in the EFI subsystem. So maybe we can look for SMBIOS. That's probably not very common. Right, and so to get back to the previous directory, I just do pop D. So there's push D and pop, push directory and pop directory. It's just like a stack. Now I'm back where I was before. Convenient little tool. So, all right, now let's make sure our cscope database is up to date.
You could explain what cscope is. I don't know if we've mentioned it yet.
Yes, so cscope, I'll be using this, other times throughout the semester, but cscope is a tool to quickly search through C language repositories. Through a number of different methods. I mean, you'll see here's the main interface for it. I mean, it'll index your repository so you can look for specific symbols, kind of global definitions, functions called by a function, functions calling this function. Find some text string. You can find and replace. You can do a general grep, and you can find particular files, and you can find things that are included, like files that include a particular file, as well as assignments. And so they're the shorthands for doing these things within Vim, but you can also just use this thing directly. So, I can show using it directly here, SMBIOS, and probably, I don't know, that could be preceded by anything and then succeeded by anything. So just demonstrate the grep thing. All right, so let's do a little search. And it looks like there's a number of places. So you see this is all occurrences of SM BIOS. But you can see there's anything before and there could be anything after, right? Some of these things have an underscore afterwards. I mean, a lot of them have an underscore afterwards. And then there's a number more. This one has a comma afterwards. So, I don't know if that's so useful. Maybe we'll look for, oh, I just got into this. So I think we can put it like that. And I don't usually use this interface, so that's why it's a little bit clumsy for me. So what if I escape Q? No, Q opens the file. And let's Windows D. Okay, so or Control D, send end of file. So I'm going to use it through the Vim interface. Like that's what I usually do. So make sure that we add the cscope database. So it looks like it was already added. We can do that with CS show. So CS for cscope. It's just a Vim plugin. So here's where the database is. We just generated it. Great. All right. So CS find, and you can see this will pull up this message, right? So we can CS find D. We can use another grep pattern. Maybe we want to find something with I don't know. Can you use space like this? I don't remember. Space SM BIOS. Space. I'm not sure if you can do this. Known search type. No, not dash E. Not sure if that's the correct way to do the grep. But maybe, let me copy that other line in so we something to work with. So here's the line. ACPI, mem attribute, mem reserve. So could come up with like some kind of regex. This is an EFI, so maybe it's in drivers, something that just has EFI or EFI something. EFI, is that its own thing? No. So EFI colon. I mean, just look for that thing. CS find EFI. Okay. So drivers firmware EFI. So that's probably an interesting place to look. So EFI.c maybe. EFI init. Because we are initializing. I don't know, SM BIOS. Do we have anything like that? So print format with EFI. That's interesting.
I bet that they're being printed like in a loop or something, because maybe it's just a loop where each one has a space printed after it. That could explain why there's an extra space at the end. Like, I feel like I worry that all of it might be, programmatically generated, right? It's like the EFI colon might be coming from the subsystem, right? And then it might just be a loop where it prints, variable name equals value space in a loop, for each of these variables.
Yeah, what it might be is this is just a message that came from the EFI subsystem, right? So we can look at the actual start kernel function.
Actually, wait, could that literally be? Well, there's this pure info, right? And it's like, never mind. I guess not, but.
So click this new tab, kernel, init, or was it tab? Sorry, CS find G start kernel. So init main.c. Okay, that is what it was called. Kernel. So yeah, start kernel. This is the first function that runs. Because we know these are the first few lines. So if we just take another quick look at for the full thing that we were looking at before. Right. we're booting Linux on physical CPU. So that's going to come pretty early. Okay. Oh, look, so there's a function EFI init here too. I don't know if this is particularly interesting. Menlock init screen info. Interesting, right? Unable to map, memory map. Oh yeah, by the way, start kernel. So this is the first function that runs when you start the kernel. It does a bunch of stuff. Boot CPU. So prints notice Linux banner and kernel command line. So this actually will help us out, right? So kernel command line, that probably comes booting Linux on physical CPU. So where's Linux banner? Let's see. Linux banner, version timestamp. Linux banner. So here we go. Linux version UTS release compile by host compiler UTS version. 6 strings. Do not touch. Oh, do not touch these strings. You can modify them in makefile and the make like by some makefile variables. I'm pretty sure. Anyway, so it prints the Linux banner, and so that's right here. Like Linux version 6.2, root Fedora 37 server, GCC, Red Hat, LD, preempt, date, right? UTS version, Linux compiler host. This looks right. This looks like pretty much what we're seeing. So, all right, we found where this line is printed. So that's a start. Kernel command line probably comes a little bit later because here, I don't think we've quite seen the command line yet. I mean, if you look at my D message, I can just load it here. All right, microcode, interesting. I don't really care about that. Linux version, and it has command line next. And it has some BIOS stuff, reserve memory, and then it has EFI information. So I don't know, maybe there's just nothing interesting to print there. Machine model, so ARM, it's an ARM virtual machine, so that's probably why. And then it printed the EFI stuff. So firstly, param, booting kernel. First args, booting kernel, static command line. Okay, saying init args, random init early trace init, schedule init, housekeeping init, work unit, RC unit, doing a bunch of inits, random init, mem cache, panic, blocking self-tests, mem encrypt init. One thing that could be interesting is, so here's my version of like something similar. Does my, looks like, right, EFI, SM BIOS. Looks like, yes. So I have the same thing right here. So it's not a an architecture specific thing. That's interesting because it looks like he was using ARM and I'm using x86. So I have something similar in my line, but my line is a little bit different. We have TPM final log, SM BIOS, ACPI, ZPI 2.0, right? And I guess the address is where these things are. So this is like EFI telling us where the stuff is, right? And then we have different initialization, ranges, all sorts of interesting ACPI information, zone information, cool. Whereas on this one, right, we start off with NUMA and then we get to zone ranges. So this is a much shorter one. I mean, I guess because it's because it is a virtual machine. So, so ACPI early init could have something to do with that because, I mean, you saw ACPI happens relatively early. But there's some other stuff that happens first. So ACPI for me, that happens after this EFI information is printed.
As it could depend on the version of the kernel.
EFI enabled, yes, it could depend on the version of the kernel too.
Because you're like
I can
not
also
running
search for
stuff.
EFI. Yes. Console init. K-fence init, early IRQ. I wonder, is any of these things, could they random early init, architectural and non-time keeping RNG unit. After dashes, parse args. Interesting. Booting kernel. So that comes from, does it have booting kernel? Like, does it have this booting kernel? I wonder where that string is getting the string from. Interesting.
But yeah, I don't know. I think it's gonna be pretty hard to track this down, unfortunately. I don't know if we want to keep going.
This is less straightforward than I thought. Hopefully it was interesting to take a look at the main.c.
Mm-hmm.
But I don't know. Here's, you know what? All right, because this didn't really work out. I mean, if there's a lot of demand for figuring this out, we could potentially look into it. I mean, my theory is that this just comes from the EFI subsystem. Like it's the string comes from somewhere else that the kernel can't really control, and it just like prints this string.
Into the same place, yeah.
But I do want to show the kernel init. This is something that's kind of cool. I'm going to show this right at the bottom of this function. It tries to run the init processes. I don't know if you've ever seen, a kernel like a Linux kernel fail to boot because it doesn't have an init process. But right when the kernel boots, it has to start the first process. And so first it tries to run sbin init, tries to run etc init, tries to run bin init, right? And these are usually links to systemd or some scripts that set up the system. And finally, it'll try and run the shell. We'll just try and run a shell. Bin sh, the most basic shell. And if nothing works, it'll just panic. And so fun fact, you can actually set this value on the command line. And for some systems, this won't work. But some systems, if you want to just get root access on the system, you can set init, on the command line when you're starting the machine, you can set init equals, bin bash or something. And it'll drop you right into a root shell. Pretty sure newer systems have security things that stop you from doing this. But if you have physical access to a machine and you can set the command line to init bin bash, you might be able to just get into a root shell on some system. So something that could be interesting. There's a lot of interesting stuff in this file, but I don't know. I think it's not going to be so interesting to get through here. I mean, we got some information. Hopefully, this was had some value, but yes, this was a failure in terms of its stated mission, unfortunately. So, any questions, or we can wrap this up.